Yeah, this is the one that's due today, right?
I think.
Yeah, good. Thank you. Appreciate it. Samari, uh, can you please use last name also? I know you're the only one here at the school, but I'm trying to get everyone to start writing their full name on everything. Because I have like 42 Kevins in my classes. And so, and all of them want to just write Kevin. So yeah. And then when teachers ask, oh, hey, do you see Kevin? I'm like, who are you talking about? I have no. So I'm working on it. All right. Anyway, so let's see. So since we're all here and paying attention right now, not implying anyone is not here. So let's start this class. So class. Yes. Thank you. Now I'm going to ask you a couple things first. So homework that is due today. That was the part CD. I think it says 1C, 1D on the top of it. That one is going to be due today. If you need any help with it, come in. Wilson time, yeah. So I still want to call it advisor because other schools, it's all just advisor. No, I'll get it in a minute. Okay, so I'll come around as soon as I'm done with this. So in our notebooks today, what page should this set of notes be on?
3, 4.
3. 3R. 3R. There we go. 3R. So on your notebook, or I'm sorry, not on your notebook, but since you are going to put this in the notebook as you go, please write on the top of your notes 3R so you know where it goes in later on. So when you're trying to organize this, when I say, hey, I'm going to do a binder check or I'm going to do a notebook check here soon. And you know what happens every time I do that? Everyone says, hey, can I borrow yours because I don't know where these pages go. Because you're not putting it in directly like you're supposed to as we go. So one of the things I'm just going to have you do, just write this down as we go to make sure we actually are keeping up with this. All right, so representing motion. So we're going to add a couple things here, and because of my lack of smarty boardness, I am going to try to add something else. So I know it doesn't work it as good, but it is copy and paste. So right here on the slide, so a basic graph model. So which variable is the rise? It's going to be here. So we're looking this as a slope. Rise over and run. Rise does what? Up and down, right? But we're slightly different on this one now because we're not doing X and Y. We're doing position over time. Position over time. So it's going to be position, my position. So that would be my delta X if I'm looking at my velocity. So that's going to be my delta X. Let's see if I could actually. The run is going to be my delta T. And the slope is V over T. Let's see if I can. Can I line up that question mark? Yes, I can. There we go. That's important because a lot of people struggle with these types of graphs because you've been ingrained so long. X is always the left and right. Y is always the up and down. But it is not because X now refers to the position and your X values, which you used to have, is going to be time. Now, what do we know about time? This is important. Think of mathematically. Think of number sense. What do you know about time? What can I not have? I heard negative time. Very good. Negative time. Can't have negative time. Okay. This is not Back to the Future. You can't do some mathematical equations and actually, figure out time travel is possible. Okay, you can slow down time, but you can't go backwards in time. Yeah, they can slow down time. Scientifically, they slow down time. You know that the space station, the one that's orbiting Earth, is actually going slower than the clocks that are here, because they actually have these. I don't know. They're like, call them like a nuclear clock or nano clock. Whatever, like the specific. The time is different on the space station than it is down here, because when they put the rocket up into space, they were synced up. They were exactly the same time. Can anyone tell me why up there?
Space rotates slower than the Earth. It revolves around the Earth slower than the Earth spins.
No, they actually go faster. So, and I think they actually do one day in about 4 hours.
Okay.
Because they're usually rotating again. So if you ever go to the NASA website, you can actually see what they're doing from the space station. They actually have a camera, a live feed that actually shows as it's going around. So, anyone else want to take a stab at it? Less gravity. So, less gravity, that slows down time. So, that's crazy, right? Less gravity, slower time. So, it's a pull of gravity that actually is what keeps our times synchronized here on Earth. So, anyway, it means that you are given displacement, position, versus time graph to find the velocity of an object during specific time intervals, simply to find the slope. So, my average velocity should be the slope. All right, and I'm going to do these ones with you over here on the board, and then when we're done doing them, I will copy and paste it for those people watching the video. Says you must be able to calculate the velocity or speed from the graph. Now, time in seconds is going to be my going to the right. So, using that information I gave you a little bit ago, will the time go to the left? We could go left, but what's that going to give me? That's going to give me what I already had in the past. But I cannot actually direct it to the negative. I can look to see what was already there by going from 50 to 40 to see what's there, but I can't move it to the negative. So time always goes to the right. All right, velocity. So velocity is going to be the slope, right? So let's go ahead from 0 to 10. Now, markers. So start this off. So my average velocity is equal to my delta x over delta t, which is, it is going to be my x final. What's my x final? From the graph, that x final. Remember, x is your top value. So it's my position over here, right? So it's going to be, my position is 60. And what is my position at the beginning? At 0? Yeah, it's 0 right here. So these are the 2 points I'm actually trying to use. So it's going to be 60 minus 0 over my time, and my time interval that I'm using is going to be from 0 to 10. So it's going to be my time final, which is 10 minus 0. Ugh. So we end up with 60 over 10, which is 6, what are my units? Meters per second, yes, meters per second. So we have 6 meters per second. Always try to pay attention and always try to label your units for this. Did I make a mistake?
Why is it not squared?
Okay, are we asking for the acceleration? Okay, because acceleration is the rate of change of the rate of change. So this one's only going to be the velocity, and velocity is always meters per second. If I'm asking for what is the rate the velocity is changing, so that would be how the velocity changes over time. So that would be, in normal mathematical terms, it would be the second derivative for that one. So we actually would go through and actually we're looking for the slope of the slope at that point. Does that make sense, or did I just totally confuse you more?
No.
Okay, so think of it like this. Velocity is what we're looking for. What is the velocity? Velocity is always in meters per second, right? Normally what we're doing, our standard units are going to be in meters per second. Where if I'm talking about acceleration, that's per second per second. All right. So this next one, what is the velocity at t equals 12 seconds? Now, am I giving you an interval here? I'm not giving you an interval. So I could actually either make this out from the graph, or I don't know how mathematically inclined with the actual previous math that you have. So feel free to say, what the hell is that? So velocity at that, we're actually going to take, it is what is the limit as delta t approaches 0. When I have the delta x over delta t. So, have you guys done any limits? Do you know what this is? No. All right. Don't worry about it then. So I'm going to teach it a different way then. So I didn't know if you guys actually have done some of this before, but I'm going to leave that off. So instead, let's look at the graph. Looking at the graph, can I pick 2 points on that graph, on that segment, that line segment there? So yeah, that's between 10 and 15. So I'm going to find 2 points because it wants to find 12. 12 is in between 10 and 15, right? So instead of actually finding at that point, we're now finding the secant line, which is in between the 2 endpoints. So for that one, it would be the same thing. So that would be my delta, which is between, what did I say, 10 and 15?
Yes.
So at 15, it is 60. At 10, it is 60. 15 minus 10. So you guys know what a secant line is.
Said it was in the middle.
It's in between. So so in a normal graph, you'll see a secant line like this. So as we're talking about the slopes, because when we start dealing with curves, we're going to have a curve. It's going to be like this. I have this endpoint right here, this endpoint right here, and if I was looking for 12 right there, what I'm going to do is actually, I would do the secant line. A secant actually connects a straight line in between the 2 points. This is a secant line connecting those 2 points. And so what we eventually try doing, and that's where the limit process comes in, is actually keep moving. So instead of having 10 and 15, we would go closer. So we would go like 11 and then move over 14 and draw a new line there. And 11 and a half, 13, draw a new line there. Draw as close to 12 as I can, and then 12.5. A secant line is going to approximate the slope because as I get closer and closer, the change in t, the delta t in this case, is going to get closer and closer to 0, so I could actually have it there. That's what limit process is. That's getting closer and closer to that point by using secant lines. So we're just estimating it off the 2 endpoints. Yes. Yeah. You can't see from there? There's a bunch of empty spaces if you want to move up here. There we go. So I'm serious, yeah. You want to move up, you can't see. All right, so now that's what it actually is for secant line. So for this right here, when we're trying to solve for t is in between those 2 points, and I know the slope of the line, since it is a straight line, is going to be the same all the way across, right? So for my example, is the slope right here, since this is a straight line, the same as the slope is right here? My slope is what? Constant, which is 60 minus 60? 0. Thank you. That's what I'm trying to get out of 0 over 5, which is 0 meters per second. So since this is a flat line, right here, a horizontal line is always going to have a velocity, a slope of 0. A horizontal line, it's almost like I'm enunciating, like I want people to write these things down. But a horizontal line is always going to have a slope of 0. Would you like for me to say it again? A horizontal line is always going to have a slope of 0. Yes?
Is that similar to one of the problems for the?
Yeah, when you do the math on it, it's always going to come up to be 0. If you're looking at a line, there's no change in my position. So that means it's staying where it is. So if my position over here at 10 seconds is going to be the same position as it is at 15 seconds, I look to see what happened. Okay, so now I'm going to tell a story with this thing. So I got a dude trying to catch the bus. Okay, he's on his way to school. He comes in late, so he is going really fast to try and catch his bus. Okay, he gets to the bus stop. Okay, what happens when he gets to the bus stop? He's waiting for the bus, right? He's waiting for the bus. So now, how long? So let's see. For this time period, from 10 to 15, he's waiting there. So is his position changing? No, he's still at that location. So that's what that means. He's staying there. He's not moving at all. He has 0 slope. There is no movement moving. At 15, he gets on the bus, and he's going to school. Okay? He had to go away from school to actually get to the bus stop. And from the bus stop, he's going over here, right? So the bus is taking him. So now from the bus stop over to 40, what is that telling me? It's going down. What does that mean if it's going down? Negative what? It's going down. What does this down here represent?
Position.
Negative position compared to where? Compared to your start, right? So if you start here, that's your origin in this problem at 0. He gets on the bus and he goes the other direction. So he was going in one direction. He was going, if I'm looking at this as a right and left, he's going to the right from 0 to 10. He's waiting at the bus stop from 10 to 15. And at 15, he gets on the bus, which goes in the left direction. It goes in the left direction because it's going down. He's going down there in the left direction. Okay? And over here, when he gets to 40, right there, what happens? The bus takes a turn. The bus turns. It looks like it's going the same slope, but it takes a turn and actually is heading back towards here. Where's this actually ending? It's ending at a position of 0. So if I look at it going left and right, so I go to left here, I'm waiting there. No, I'm sorry, got it backwards. I'm going right here, I'm waiting, I go left, and in the end, the bus drops them off at home. So he's back at the 0 position. So my position is 0, so that means that it is my starting, wherever I'm starting at. So if I'm looked at left and right type of thing. So let's try this next one here. So we have a velocity, 0 meters per second, and the last one right here. What is the velocity from 15 to 40? So write out your equation. So my equation is going to be the average velocity. It is delta x over delta t, which is going to give me, so we're looking for x's now, my position. What is my x, my final position on this one? Okay, I'm going from where to where? I'm going from 15 to 40. So my end time is 40, right? So it should be
0.
what?
40.
It's going to be negative 40 because this is my position right here. So it's going to be a negative 40 when time is 40, right? It's negative 40 minus, okay, what is your position at 15? It's up here. It's going to be 60. Over my times, which is 40 minus 15. All right, so negative 40 minus 60 is going to be negative 100 over 25, which is going to give me a negative 4. What are my units? Meters per second. Very good. There we go. All right, so the people watching online actually have something to write down. Now, I want you people right now, with the information I've given you so far up into this point, I want you can talk with your people in your group, explain this one and this one. Explain them both. You can even compare them too. So you're going to explain them. So what is it? What descriptions can you tell me about these things? What do you know just by looking at the graphs? So you can talk with the people at the group. All right. All right. So anyone want to share what we have for the first one so far? As long as no one has earbuds in and I know that they're paying attention right here. Not implying that anyone in here in the front area actually has earbuds in while I'm talking. Because that would be not good, because you can see it right there, right? So anyway, can someone right here tell me, give me a guess. Give me something, a description of this. Go ahead.
Could it be that the top one is like,
It's positive, right? Very good. Positive velocity, so that means it's going in a positive direction, right? Yeah, that's good. All right. Anyone else? What do I know about the slope? It's what? Okay, and it's steeper, so it has a steeper slope than down here in the second position, or the second one over here. What can you tell me about the line though?
constant,
It's what?
constant.
Constant. It's constant. The slope is the same over every single point on the line. So that is a constant speed. Acceleration. Can you tell me acceleration? It's important.
top will accelerate faster than the
The
The top will accelerate faster than the bottom.
nope, they actually have the same acceleration.
Um,
Go ahead. Like seriously, it's I want you guys talking through this, and so everyone just being quiet. It's okay. So let's see. You look like you have an idea. What can you tell me about the acceleration? We just stated that the velocity is positive, right? Okay. And it is constant, right? So that means that the velocity, if it's constant, that means it is going to be the same over everything, right? Over the entire line. Give me a guess for acceleration.
It's also constant.
It is constant. It is? But what is it?
Acceleration.
Acceleration?
Mhm.
And think about it. You know, mathematicians kind of say that it could be positive, but it's not. Huh?
Zero.
It is zero. Why is it zero?
It's not going negative or positive.
It's not going negative or positive. It's not changing. If it is not changing, the acceleration is not changing. So if the line is constant, acceleration is zero. It's not slowing down. It's not speeding up. So this one right here, we stated it is positive direction. It is constant. And this one right here is going faster than the bottom one because they're both about the same, right? So yes. And there we go. All right, close enough. And if you're watching online, pause the video so you can write this down. Okay, there we go. All right, now, you people, I want you guys to try to explain these. We went through the things that you should be looking for, that you should be saying on the previous one. Now, you should have a couple things that we're talking about, that we're saying, the things that we're looking for, everything that we're adding to this. You can talk with your group. Actually, you need to talk to your group. I don't care if you just say left, right, negative, positive. Say something to the people at your group.
Increase the velocity
All right, did you say anything to her? Okay, I need you to have these out. Anything? Ask me.
But I can't
I don't mind if you say it like that, but that's, at least enjoy the conversation. Okay? So, now, what do I need? One line right there, right? No, it is a line. Isn't that what I said, one line? Not lenient it? One line, okay. Anyway, so, the line is straight, right? It's going in which direction? It's going in the opposite direction.
I think you need more sleep.
So, look at this line. It's going what? Negative direction, right? So that, what are we looking for here? So it has a negative, such a and slope. Yep, so it has a negative slope, right? So we have a negative slope. What up? And so that means it's going to the negative direction, right? What do we know about the shape of the line? It's straight. And what do we say about straight lines? Constant velocity. Very good. So whatever the slope is constant, right? And what do we know about acceleration? If the velocity is constant, acceleration is. Right, I've been wanting to play with this all the time. We're doing 25 miles an hour. 25 miles an hour. We're still doing 25 miles an hour. So are we accelerating? Are we decelerating? So if it's neither acceleration or deceleration, that means what? So the acceleration is going to be what? Is there? Are you accelerating?
Did you see
You're 25 miles an hour, right? 25 miles an hour. So it's staying 25 miles an hour. So am I accelerating or decelerating? Neither. So acceleration is, thank you. That's what we're looking for. I've one reason to actually play this thing. Because you actually have a trailer for yours. I don't have a trailer on mine. I'm gonna 3D print my own trailer for mine. All right, let's go through here. First one. Someone throw something at me for the first one. Zero. What about zero? Zero. Zero acceleration. There we go. Okay. Why do we know it's a zero acceleration? What is constant?
I said the both of them.
You said what?
I said the both of them. I said all of them.
Yeah, but no, if I say it again, remember, slightly hard of hearing. Slightly hard of hearing. So I need, if I'm like, huh? Yeah, and don't second guess yourself. Say it again so I can hear it. So that's all you're saying. You're just, yes, we give him credit. Okay, he's getting all the brownie points for this. You are the greatest. You have said it all. So now can we go back to what it is that you were saying?
Yeah.
Okay, what'd you say?
It's constant.
What's constant?
Velocity.
Velocity is constant, and
It's zero.
what is zero?
Velocity.
Acceleration.
Acceleration is zero because the velocity is not changing, right?
Velocity is constant.
Okay, it's not changing. It's staying a straight line. If it's a straight line like this, the velocity is staying the same all the way across. So that means if I'm going down, what can someone tell me about it going down? It's decreasing. What does that really mean though, decreasing?
Slowing down.
It's not slowing down.
It's changing position.
Changing position. Which direction is it going?
Right. Left.
It's going towards the negative, isn't it?
Yeah.
Okay. Did we start at the origin?
No.
No, we didn't start at 0, 0 like we normally do on a lot of these graphs. This one starts way over here, right? So I'm starting off at a far away distance. My distance is far away. And it's going in a negative direction. It's heading towards my origin. It's heading towards my distance being 0, my position being 0. So once it gets to this point way over here, which is not really touching, that means that my distance is going to be 0. But then from that point, if the line continues, it would be going past my home. Or if we're doing the analogy of the bus, so guy on the bus gets on the bus way over here at time equals 0. So the bus is going towards home and it stops right there. So what can I say in that analogy in my story?
Wait, your analogy?
Yeah, in my analogy,
Oh, you're home.
is he home? When he gets there, he'll be at home, right? The bus would have
Drop him off.
at his house, right? And that's going to be at 0. But since there's a gap right there, the bus driver was kind of a jerk and didn't actually leave him at his house. He left him at the end of the street or something. Like he pissed off the bus driver and the bus driver left him at, somewhere else. Word of advice, don't ever piss off the bus driver. So, next one. Someone tell me something good about the next one. And I would like to hear from people I have not heard from yet. Maybe someone in this area. Okay, I want to hear something over here. Someone over here, give me something with this. The line's curving. Very good, very good. Oh, is there a direction for the line curving? It's curving which way? Positive. It's going up, right? So if I'm thinking about velocity, think about velocity. Velocity is my slope, right? As I'm starting here, what can I say as it's going up, right? What do I know about the slope at this point right here when I start? It looks like 0, right? Slope is 0. But as I go over here, slope's positive, and then slope way over here, it's a bigger positive, right? Slope way over here, it's an even bigger positive. So if this is not a straight line, I am going in what direction? I'm going. Someone over here, help me out. East. East. No, this one's going to be going positive because it's a positive right here. Look at my distance. The position is my distance. How far is it away? It's going further away. Okay? From this line right here, it's going further away. So that means it's in a positive direction. So my slope is positive. And my velocity is, it's increasing, right? So my speed is increasing. So now that's important. Okay? All right, I got to borrow the truck for this. You ready? Okay, I got to borrow the truck. Okay. So now I got the truck right now. Ugh, this is Chevy, gross. Sanitize my hands afterwards. Anyway, so right here in this truck, started off slow, the velocity, and then picking up speed. So going faster and faster and faster. As you're driving, what do you know about the truck? The truck is doing what? Getting faster. That is accelerating. So it's accelerating. So that means that it is
Stepping on the pedal.
stepping on the pedal. Is it a positive acceleration or is it a negative acceleration?
Positive.
It's a positive acceleration because it's actually going faster and faster. So it is a positive velocity and it's going to be a positive increasing acceleration. Thank you. Your truck is getting a workout today. All right. And okay. There we go. And, oh, yes. Forgot to add that one. So yeah, it is increasing. So it's increasing. So right here for the type of line, this is concavity. So it's going to be concave up. So it's actually going to be increasing at an increasing rate. So that's important when we're actually talking about this. We're talking about our types of parabolas and the slopes as it's going. Because concavity is going to be important for your math class at some point. I don't know what math classes you guys all have, but breakout, yes, they'll do concavity. All right, next one. Actually, do you know what? I'm going to leave off here. We're going to start class with this one here tomorrow. Make sure you all like, share, and subscribe.